This is NK Tech. So in front of you is a rather nice and simple DC to DC boost converter based on the TL494 PWM IC. So it's a switch mode power supply PWM driver IC used in many switch mode power supplies such as the complicated power supplies. It requires just a handful of components for biasing. So the connections are shown. Pin 12 is the VCC, pin 7 is the ground pin, pin 1 and 2 are the input, the air amplifier inputs, as well as pin 15 and 16. The reference pin 14 generates 5 volts when the IC is powered. So the output control is pulled up to 5 volts so that it does not determine the output PWM. In this case, the daytime pin 14, since we want minimum daytime, it's grounded, so the daytime will be 3% by default. The CT pin is connected to a 2.2 nanofarad capacitor as well as the RT to a 10 kilo resistor. These two basically control the PWM frequency, and with such it's about 45 kilohertz, which is good for the switch mode power supply. So to control the output voltage, you have this feedback network made of these 3 resistors and a trimmer port, which is being fed to the non-inverting terminal of the first air amplifier. So then we also have current regulation, whereby this ensures that the current drawn on the primary side does not exceed a specific value. So the connections are shown here. So the open correctors of the 2 internal BJTs are pulled up to 12 volts, and so the emitters are used directly to drive these MOSFETs. So when each transistor is on, basically it means that the respective MOSFET gate is pulled up and the MOSFET conducts. So if you look at it, you see that it's a push-pull DC to DC converter or switch mode power supply, since the input VCC is connected to the center tap and the MOSFETs are connected to the other half winding terminals. So for the windings, you have the primary is 4 turns on each side with 3 wires in parallel of 14 gauge AWG wires, while for the secondary you have 6 turns each half. The same case for 14 American wire gauge, two pieces each. So you can adjust the secondary turns as you want. If you want higher voltage or lower voltage, like you can have, say, 12 volts on each half to obtain 48 volts, or if you want even higher voltage, you can go all the way to about 32 volts. So basically, when the first BJT, this one, is on, you can see this first MOSFET, IRZ46 MOSFET, they are powerful MOSFETs, they can handle up to 40 amperes, will conduct, and so current will flow from VCC to this half winding to ground. So when current through this current sensing resistor flows through, a voltage will be established, and this will be fed back to the current feedback terminal, which is the second air amplifier. And once it exceeds a certain voltage, so basically this air amplifier will be activated and the PWM will be limited to ensure no more current flows through, since it can damage your MOSFETs or destroy your battery or even fry the windings of the transformer. So when this transistor turns off and this other one turns on, basically it means this other MOSFET will conduct and current will flow through the other winding. So this way the transformer is hand reset every time, and so meaning that you can use as much duty cycle as you want. You can increase the PWM frequency, but ensure you do not exceed about 100 kilohertz, since it won't have any much effect either, and it will lead to complications in the filtering network at your components. So this is the input capacitor. On the output, you just have a Schottky rectifier diode and this filter section made of this inductor and this capacitor. It's a pi filter, and here you have your output. Then here you have your ground. So that's all, folks, about this video. Please ensure that you like this video, comment below, subscribe to my channel for more amazing projects.